The first type, and one of the oldest type of hydroponics, is deep water cultivation. Okay, simply put, okay, is floating plants, okay, on water. There are many ways to do it, but often a styrofoam board is placed over a tank. There's an air stone, okay, to provide oxygen. The water is nutrient balanced, and the plants float and the roots grow. Usually the roots will suspend down about 6 to 18 inches, hence the word deep. These are deep channels. It's a simple system. The only thing you really have to worry about is electricity for your air pump, and of course the quality of your solution that is inside the tank itself. In the wicking system, plants are grown in an upper tray with water. Then there are wicks that go down into the nutrient solution with an air stone to put oxygen in the water. Okay, the nutrients wick on up and nourish the plant's root. As wicking systems are one of the most basic of the passive growing members. It's sort of similar to the deep water cultivation, except that the plants are placed up in a shallow dish of water where the roots are, and then wicks are brought down into the nutrient solution. The nutrients, of course, will wick on up into the root area, and the plants will grow. This particular type of system is really only suitable for small plants. It is very inefficient when it comes to nutrient use, but that is one of the systems. Now, this is the drip system. You'll see there's many forms of the drip system which we'll go through, but in the simplest, plants are placed up in a tray and suspended. A water pump, sometimes on a timer, will take the nutrient solution, which is oxygenated through an air pump or other means, and then pumped on up and then dripped in through emitters into each of the plants. As it goes through the medium, the roots absorb the nutrients. Water drops down to the bottom of the tray and returns down for recirculation. This is a pretty common system, and it's pretty efficient. There's plenty of oxygen going to the roots. Problem is you're dealing with a lot of water. Another type of drip system is called the non-return system. The method of operation is pretty much the same. The nutrients are pumped up to the plants via emitters, usually on a timer, except that the water which is collected in the bottom of the tray or through a collection pipe are actually discarded. It's a once-through system. The once-through system is common where during the growth cycle of the plants, different nutrient blends are needed. Sometimes on a weekly basis, you'll be switching out your nutrient blends, and the blends are different enough that it's very hard to maintain a single mix. Another system is called the ebb and flow system, or flood and drain. There's several different configurations. This particular one shows a flood tray. On a timer, the pump will pump up the nutrients to the flood tray. It fills on up, covers the roots, then slowly drains back out, exposing the roots to the air and getting their oxygen. It's a heavy system because when you fill up this whole tray with water, it does get pretty heavy, so you have to make sure it's braced correctly. It's easy to make, and it's easy to maintain, and you can grow just about anything in here in these particular flood and drain trays. Okay, the next system is another ebb and flow, and it's called the Beto bucket system, or Dutch bucket system. This is the Beto bucket, a cross section. The nutrient mix is supplied through a feed tube into the bucket. The plants are put in an inert medium such as clay pebbles, which are light, not quite buoyant, and easily disinfected at later dates. And that's designed to support the roots. But when the water fills on up, Okay, the siphon elbow, which actually is can evacuate the water faster than the feed tube can put it in, will drain the level all the way down to pretty much near the bottom edge here, as shown in this illustration. And then the oxygen is actually drawn in through the pebble medium to the roots. And this process repeats itself automatically. The nice thing about the Beto bucket system is that you can put in up to 3 plants depending what they are inside of each bucket. You can grow large plants in there, such as vine crops, such as cucumbers, tomatoes, just by adding a trellis up here and tying up the crops themselves. It uses much less water and nutrients than the deep water culture and is a lot more efficient than the wick system. The only disadvantage is that in some systems the drip lines can clog, and if you're using an emitter, which would be down here, they'll clog up too. Second problem is some systems actually use a flexible tube here with a punch fitting in here, typical drip irrigation fitting. We're not doing that. We've switched over to a more rigid silicone pipe. We'll put a hi-hat gasket in here, and then we'll use a 1/4-inch tubing through the feed tube. Flow into each bucket is controlled by a back pressure valve, so if we need a lot of flow, we can just close down the back pressure valve. If we need less, we can open it up. Second thing is, by using the hi-hat gaskets, we can actually plug off a bucket. So for example, if you have a 10-bucket system, you can isolate the buckets just by shutting off the water, removing your feed tube, and then putting a 1/4-inch plug in. That's something you cannot do with the typical emitter system. One of the more common systems is channel system, called nutrient film technique. In the channel system, okay, water is placed in a channel which is on a slope and runs a thin film of water down to an exit back and returns back to the nutrient reservoir. Again, this can be on a timer or not, depending on how you have your system set up. The nice thing about this is if your channel is designed correctly, you have plenty of rooms for the roots to grow. You'll find that the roots themselves will actually grow down and follow the water path down. Sometimes if you leave them in too long, these roots will be 2 to 3 feet long. However, if, like I said, your channel is designed correctly, all the plants will grow just fine. The big advantage to the nutrient film technique is conservation of water. These systems will use 80 to 90% less water than conventional farming, and a lot less water than a Dutch bucket system or a deep water culture system. This cuts down on your cost of nutrients. Nutrients are dosed in milliliters per gallon. The last system we're going to show is called aeroponics. Aeroponics is a special type of hydroponic system. Again, you have a water reservoir, you have a high pressure pump which goes up to spray nozzles and sprays the nutrient directly upon the roots. This uses much less water than even an NFT system. Water, of course, the nutrient water that falls off the roots is recycled and brought back again. The big problem with almost all aeroponic systems is drowning of the roots. Okay, so too much spray is a problem. Okay, too little spray doesn't bring enough nutrients in it. Aeroponic systems, although they're out there, are not that efficient. You do have some issues on that. It's a matter of control of the spray, the droplet size, and the duration.